Right, 2019, Section B, Question 2. The image on the right shows the Lacey Bridge in Drogheda, County Louth. The projections of the bridge are shown in figure B2 below. So part A of the question says the curve ABC. So ABC here. Curve ABC here. Where is my plan? Didn't give it to some plan. In elevation, ABC, a parabola in elevation with the vertex at B. Draw the given elevations. So that's very simple. That's A, B, C here. We got a rectangle method. We got the vertex at B. The curves D, E, F, part B then. The curves D, E, F and PQS in plan are branches of a double hyperbola. The vertices are at E and Q. The construction for the portion DE of one branch is shown. HLG is a straight line. Draw the given plan. So DEF and PQS are branches of a double hyperbola. They've actually gone on, they've shown us the construction for the portion DE, one branch shown. So they've given us the construction already, so we don't actually even need to think about this. We're just looking here. We divide up the distance between D and our axis here split up into 5 equal parts. We can split up into whatever we want. We join those points back to Q. We then divide up the distance between the vertex and the end of our curve here where we're drawn to. We split that into 5 equal parts as well. We join that back to our vertex, and then it's just about matching up the points, and then it's just translating them from axis through flip them over, bring them down, measure them over, and same, bring them across there and step them across. So that's, and then the HLG here is a straight line, and draw the given plan. So this is pretty much, like, there's nothing in this that's too complicated. Like, they give us the construction here to draw this. Everything else then is just a straight line. This is just an arc with a compass. And yeah, that's it. That's pretty much handy enough marks. Part C then is, in the elevation, the focus of parabola ABC is located 4.9 meters from the vertex B. Locate the focus and draw a line which is tangential to the parabola at point C. So they've given us where our focus is, so it's going to be in here somewhere. Okay, we'll measure that inside there. Principles then for when we're drawing tangents to any conic section. Okay, so if we had an ellipse here, it was given a point on the curve, which we have, or given the axis, we have our two focal points. We join to the focal point, bisect it, and then join through, and that gives us the tangent. For parabola, what do we have? Well, we got one focal point here, and we got our point here. What's our principle? Well, we still join to the same focal points, join the point to two focal points. But where is the focal point for a parabola? Well, it's lying out at infinity. So if it's out at infinity, if it's like in the ellipse is over on here, so the further it goes, this line gets flat. So if it's at infinity, that's a horizontal line there. So we go through the point at a horizontal line, join that up, bisect that angle there, and where that cuts through, that gives us our tangent. So that's actually, if you know that principle there, it's handy enough. And that's the same for any conic section, when you have a point on the curve, join to the two focal points. Okay. So let's start this question off here by drawing the curve ABC is a parabola in elevation with the vertex at B. Draw the given elevation. Yeah, one thing just to have a look here is our scale. It tells us our scale is 1:100, so that's nice and handy for us. So for argument's sake, if I have 8.1 meters, 8.1 meters, that is 8,100 millimeters. So I'm going to divide that by 100, so that give me 81. So my millimeters there is 81. So I'm dividing all these by making sure they're in millimeters first, so adding a 0 onto the end of them to make them millimeters, or multiplying them by 1,000 meter. Yeah, so multiplying them by 1,000, so I move, yeah. So I multiply all these by 1,000, and then I divide them by 100, and that gives me my scale. Because I'm multiplying by 1,000, so I get them in millimeters, and then for every 1 millimeter I draw, and that actually represents 100 in real life, so I'm dividing by 100. So this is simple, it's 81. Okay, so I'm going to start off then by coming down about, sure, keep this top of my page, so I'm going to come down about 100 mils, say, and that's going to give me my XY line. Okay, so up on there, I should be drawn in heavy. How's it? So my XY line. Okay, the width of it there is 252, so that is 252. So I'm just going to sit up roughly in the middle here. Boom. Boom. Okay. And this is going to be my rectangle here. Measure up my height, which is 81. Now, the middle of this is 252. Divided by 100 is 125, 126. Just double check that. 126, yeah. 126 there. So that's the middle. So that's my vertex up there. B. That's A. And that's C there. Right. How do I go about drawing this? Well, just having a look here now at this, this is already divided up. I don't have to do it like this, but it probably makes sense because I can divide this into any number of sections, draw my parabola and join in these afterwards. But this is divided up here into 1, 2, 3, 4, 5, 6, 7 sections. Okay, so if I divide up this line into 7 sections, I'll get those lines automatically, so it'll just save a bit of hardship afterwards. I'm going to divide this line into 7 sections, and if I divide that into 7 sections, I also have to divide my side into 7 sections. So I'm just going to take my compass. I know my compass is a little bit off there, so I'm just going to draw them out here. So 20, 40, 60, 80, 20, 40. That's 7 sections there. I'm going to do the same up here then. So here I'm just doing my divisional lines. My divisional lines principles. So if I join this back to the end of that, just split these up here then. Just slide my set square along here parallel. All those distances then will be equal. Okay, and if by right, they should be all 18 mil. So we'll just have a look at them there. Yep, bang on 18 mil. Do the same up the side here. Perfect. Okay, so all these points go horizontally up. Here, so I'm just going to take that distance there and just step off over on this side here, just translate it across. And the other one straight up as well. Okay, so this is just the second half of the parabola. I'm just solving it here. And you know what, I can just bring these distances across here. Now these don't go across here, okay, my side ones. So I always try and, my way of remembering it, or my way of trying to explain it is opposite to the vertex goes back parallel perpendicular to the vertex. So the opposite side of the vertex goes perpendicular. 90 degrees or to the side of the vertex, it goes back to the vertex. Okay. So back to, so my side ones here go back to my vertex. I said any detail in a red pen here is construction lines. So they're nice and light. Don't want to be able to see them. Okay, and same on this side. Okay. Yeah, this is just going back here then, and we are starting off just letting in our points in along up on here. And we're freehand them in. Same on this side then. Probably best off just to mark them first. See where you're going. Okay. Now you can rotate the board around if you want, just to make it a bit easier. But I can't. I just want to leave it set up there because the camera won't be able to catch it. Okay. So that's the first part of the curve ABC. That's part A done. Okay. So on to part P then. Okay, the curves DEF and PQS in plan are branches of a double hyperbola. The vertices are at E and Q. The construction for the portion DE of one branch is shown. HLG is a straight line. Draw the given plans. This is the first part we want to deal with here. The construction of the double hyperbola DEF and PQS. Okay. The vertices are at E and Q. Vertices are E and Q. The construction for portion D of one branch is shown. So the shown is here how to do this, set up this branch here. So we're going from the vertex of the opposite hyperbola back to our line here, which is between the axis and our point that we're drawing it. And then we're dividing up the distance here. So I'm going to go through that there now. So first of all, I'm going to just get this line set up along down here. So it's 80 mil, so I'm going to come down. 80 mil from here to here. So I am just going to come down. I'm just going to come down down to roughly into the middle of the area here. So 90 there, way about there. That's roughly where, yeah, I should fit it in there. Should fit it in there. So this is my axis along here. That's my axis down there. And I'm going to take the center of the bridge down, so I need to make sure that I transfer the middle of my bridge down here. Okay, so it's telling me the width of the road here is 4 meters, so I'm going to come up 40. Down 40. Out to the edge there, and that just gives me the box then for these double hyperbolas. It's double hyperbola. Okay, it's telling me here that the vertexes are 3.6 meters, which is 36 millimeters now drawn from the center vertex. 36. And that's E and Q there. And then we've got D, F, P, and S. Out there. Lovely, we have all them. We do. Okay, so just leaving it at that there for a minute. We're going to draw this here. Like, they've given us the number of divisions and everything here, because they're showing us 5 divisions here, gives us this line here, they've given us this point, so they've literally done everything here for us. So all we're doing is copying this, okay? There's nothing complicated in this at all. All they're looking for us to do is copy this out exactly. So that's what we're going to do. So we're looking here between the vertex, between our axis and our point out here, D, we've got 5 divisions. So let's just go out and we'll do that again. Divisional lines again. Out here to D. I'm going to split this up into 5 parts. 1, 2, 4, 5. Take those then. And I'm just going to join them back there. Okay, so they come straight back, and again it's the same. They are going opposite the, no sorry it's not. So these points here are going back to our far vertex, okay? So they are going back to Q on this occasion. Okay, then what we need to do is same again, divisional lines again, but it's along here between D and E, along this straight line here, D and here. Okay, so just bring that line out there again. I'm going to do division lines 10, 20, 30, 40, 50, just split it up into 5 equal parts, random, doesn't matter. It's handier here because I don't have my good compass to be doing this. So join the last one back to our edge of our line and slide the rest of the distances parallel. Perfect, and these then are going back to our near vertex, which in this case is E. Okay, and then all we're doing is matching up our points again. So there's 1, 2, 3, 4, and it goes all the way back down. Sorry, I'll do that again there. So it's 1, 2, 3, 4. They go all the way back down to D. Okay, now we could do the exact same down this side and do the exact same over here and here, but it just gets very messy. And because it's a double hyperbola, they're all symmetrical. So what I can do is I can take those 4 points there, drop them straight down. 1, 2, 3, 4. And axial symmetry then, distance there, step it across. My distance there, step it across. Here it's actually tricky enough. Here, step it across. And the last one then I'm just going to measure here because my compass won't get in. So it's 1, 2, 3, 4 mil. 4, and there we go. Freehand curve that then up to the top there. Okay, so that is our second side. So again then, all we're going to do then is to form the other curve on this side. Is just bring these points across here, straight across, and we're going to do axial symmetry again. through the middle of our bridge. Okay. So there's numerous ways you can drag them all across. You can drag one across, you can join them up. I'm just going to draw them all across there and take the distances up. Just make sure you're making them in the right place. This point across, same point on this side. Here. And our last one then is this one here. So this swings up around. There. That's the two branches of our double hyperbola. Now, if we're just looking here, the G here is found by running this line through the middle here and where it crosses coming up from our E. So it's our second division here, 1, 2. So it's this one. Second division. I'm going to draw that lightly across. Take that distance there. I'm just going to swing it down, just have it on the other side. Okay. And then they're on these points here. So that is our points there. Now we're looking for a radius. We have, what is our radius? They don't give us a radius here now. What do they give us? They give us point G, that's fine. Here we go. So they're giving us this is a right angle here. So going right angle from this outline there. So how do we get that? Well, first of all we have to do is find the line HLG. And how do we find the line HLG? Well, we have point G there. We managed to get point G. Point L is horizontal across from D, and it's the second division down from elevation. If I drop that division down, there we go. That's my point L. And G and L is a GLH is a straight line. So I can just continue that straight out there. And that gives me that distance there. So I'm going to draw in all those lines now quickly. Again, a lot of this is just axial symmetry. Take it from one side, bring it across to the other. Make life easy for ourselves. Okay. I'm going to join them up then. I'm going to finish this off here. Okay, last bit here now, and we're just to find this little curve here. Well, perpendicular here to this guy from this point here, so perpendicular from one of these lines, from where it meets the road here out to hit our axis gives us our center of our curve. So I'm going to set up here perpendicular. I'm going to continue a line out there, and then perfect. There is the center of our curve. Lovely. Fits perfect. Same on the end here. Slightly just goes off my board. Anyway, I can put my black pen in here now for a second, just to heavy in that curve. I don't think so. I don't seem to have a black pen here that'll fit into my compass. I don't, so I just have it in there freehand. So this will be done with a compass. Oh yeah, I don't have one, so I'm just going to heavy it in here. That's the compass there. So that's that day done. Our last bit of do now is just finish off the two outsides of the road there. So heavy, dash dash dash, heavy, dash dash dash, heavy. Same at the top, heavy, dash behind the curve in a straight line, heavy across the top, heavy, and dash behind the curve in the line. Okay, and that's part B of our question done then. Okay, so last part of the question says then, part C, in elevation, the focus of parabola ABC is located 4.9 meters in the vertex B. Locate the focus and draw a line which is tangential to the parabola at point C. Well, we talked about this already, so we have to first locate the first focal point, which is on our axis here. So this is my vertex, and my focal point is 49 millimeters away from my vertex. Perfect, that's F there. Okay, F1. What we have to do then is we have our point C out here, which is on the curve. So our principle is when we have a point in the curve, we join it to the focal point. So I'm going to join from C to F1. Okay, extend it out there. My other focal point then is somewhere out along here in this direction. Okay, what distance? We don't know exactly, but it's because it's a parabola, it's at infinity. We know it's at infinity because it's a parabola, because this curve continues on forever. So the further this curve goes back this way, the more our parabola comes up. So our focus is at off out here at infinity. So if it's at infinity, what we do is we go 90 degrees to the directrix, which is out here, through the point. So we already have that set up there. So that there, this line here is heading off out to F2 at infinity. F2 at infinity, and that's for a parabola only. Okay, so that's the key little thing there. And once you have that, then the rest of it's very easy. All you're doing is bisecting the angle. Stick your compass in, swing a curve. Step it out, and where that crosses, cuts then, join it back to our point, and that's my tangent. Obviously our normal then goes, normal then is perpendicular 90 degrees to that point through there, and after that then, that's that question. Oh, last bit, I actually missed out one part up here, just finishing off the elevation. We just have to heavy in all those lines there, but yeah, you get the idea. That's only the last little bit to finish this question off. And my OCD is killing me here. I have just finished off. Mother sitting in the background there now waiting for this question just to be finished so she can start listening to loads of waffle on her phone there. So yeah, that's the question there then done. Okay, red is in light and black is in heavy. Perfect.